Before I start, I want to remind you that precision measurement, according to the province, but I mean, they can't really tell you what to do. Precision measurement, this is back to like page I. It's supposed to take you anywhere between 10 and 15 minutes. And of course, that's like assuming that you're refreshed, you remember everything, right? You don't remember everything, correct? It's probably not fair. But I'm going to give you 10 to 15 minutes. Right now, cold turkey, would you be able to do the precision measurement question? So I think that's like 4 pages. 1, 2, 3, 4, 5. 5 pages. Try to answer all of the precision measurements in 10 to 15 minutes. Let's see how it goes. I'm just curious. Okay? So I am pausing. All right. Well, if you tried it, way to go. And maybe you weren't quite sure what to do. So this lesson is supposed to do just that. Precision measurement. Let's do a little bit of a recap. What is precision? Yeah, the smallest increment. And so it's the smallest amount it goes up by, that device, right? So I don't know if you remember, there could be a picture, right? Or it could just be a value. When you're only given a value, you have to go with like the smallest, like the smallest increase that is visible on that number, right? Picture, remember this one? Precision is high minus low divided by gaps. This is one that I gave you there. That's what you could use because they've done all kinds of pictures over the years. And so sometimes it's easy to tell, sometimes it's not as easy to tell what the precision is. Oh, you don't have it? All right. So when it's a value, let's say example, 124.08 kilograms. What would be my precision there? It is found right here, 0.01. Yes. Because we don't have the actual device, right? We can't see the actual device, so we base it on that number right there. Because think about it, this thing could go up by 0.01, so it could be 124.09, or it could be 1.24.07, right? So it tells you that this is the smallest amount that this device that was used to come up with this measurement can go up or down by. What's uncertainty? Uncertainty is found by you go precision, whatever you determine to be the precision, you divide it by 2, right? You divide it in half, okay? This is universal, so whether you get your precision by using this formula or just by looking at the number, this is how you get your uncertainty, okay? All right, so when it wants us to state the amount of iced tea using this format, let's focus on the measurement first. What did you determine to be the amount of liquid in here? How many liters? This would be 1.5. So yeah, this 1.75, because look, there are 1, 2, 3, 4 quarters basically from 1 liter to 2 liters. So you know this is going up by quarters. So this would be 1.75 liters plus or minus. I'm going to say something here. I will say this, round to the closest, to the nearest marking. Okay, that's very important because sometimes they've had liquid or amounts in there that, look at my pencil, they may have done it like just past the 3/4 mark. So whichever one it's closer to, you round. So let's say it's closer to 2, then you round to 2. That's actually how you're supposed to do it. So it doesn't happen very often, but it has happened. Plus or minus the uncertainty. What do we need before we come up with the uncertainty? You need to precision. So let's do that here. Precision. High minus low, so 2 liters minus 1 liter divided by how many gaps are there? 1, 2, 3, 4. We already determined that. So that's 1 liter divided by 4, which is 0.25 of a liter. So this is your, sorry, I should not be doing this. I should not be underlining or anything because that's my precision. Okay, that's my precision. The uncertainty is 0.25 divided by 2, and that is 0.125 of a liter. So that is the number. This is the number we're interested in attaching to this answer. Does that ring a bell? I hope it does. So 2 marks for that. 1 mark for the correct amount you determined, and 1 mark for the correct uncertainty. Okay. Not too bad, eh? You've seen this stuff. Like, I know you have. You may have forgotten. That's a totally different story here. All right, next. How about this one? I would hope you would know how to answer this one. So the competitive swimmer, the time is 28.17 seconds. State the precision. 1 mark. Look at the top corner. So this is just, and remember, state, you're not calculating. You're really just looking. So precision is 0.01 of a second. So you got to make sure you have units there. And the reasoning, I will say this. This could go 28.16, right? That's the one below it. Or you could go 28.18, right? Regardless, right? This went down by 0.01. This went up by 0.01. So 0.01 is your precision here, okay? A whole page for this. What a waste, right? At least do like a B part, right? What's uncertainty? But anyways. Next page. Kenneth wants to build a shelf with a width of 59 centimeters plus or minus 0.02 centimeters. So this is measurement plus or minus the uncertainty. State, see how it says state? Let's highlight that part. State basically says it's not a whole lot of work here. That's what it's saying. 1 mark, correct? What's the maximum acceptable width of the shelf? How do you get your max from that? 59 plus 0.02. That's just it. That's just it. 59.02. And if it says state and it's only 1 mark and you're like, this is too easy. No, it says state, right? You're not doing a whole bunch of formulas or anything like that. This is it. If it asks you for what's the minimum, you would subtract, right? So let's do that here. I'm going to circle this because that's my answer. But min would be 59.02. That's 58.98. Centimeters. Don't do this on the exam, okay? Don't be like, oh, I'm gonna go above and beyond. Like, don't do that. This is just for review purposes, okay? Because if you get that wrong, we actually take marks off. Like, let's say you want to show off and you just go above and beyond the question. If it's wrong, we still take marks off because you're showing us, wait a minute, you're not understanding, right? So just leave it. Same thing with probability. Don't turn it into a decimal unless you have to. Leave it as a fraction. Okay, next. Oh, choose. This is just a multiple choice. It's just a one marker. Choose the letter that best completes the statement below. The range of acceptable measurements. Anybody, like without looking at the options, what does this range of acceptable, something is acceptable? Tolerance. Yes. D. Circle or put the answer down there. That's tolerance. The uncertainty of a scale. Wait a minute. Like it says the uncertainty of a scale is 0.25 grams. What is the precision? This one threw students off because I always showed them to go from precision to uncertainty. So how do you go back to precision? Right? Because we know that uncertainty is precision divided by 2, correct? Yeah, you multiply by 2. It's the opposite. So how about we write that down? Like precision, remember cross multiplying and dividing? Good old, that's really what's happening here, by the way. If you go, like, if you know your uncertainty, this is your unknown, you go 2 times u divided by 1, right? So that's precision is uncertainty times 2. This one threw students off. They didn't know what, a lot of students didn't know what to do with it. It's like, hey, where's my formula for this? So we're just going to go precision is 0.25 times 2. So that's 0.50 grams or 0.5. But because this is precision measurement and this is 2 decimals, right, I would just keep it to 2 here. This is the final answer. So we're kind of speeding through this section. I like actually if you give it a try first and then I go over it, I think it's a little bit more, it has more meaning to it because you've read the question before. And again, state, right? State means not a whole lot of work. Calculate is usually, right? Okay, formula, a bunch of calculations. Let's go to the next one, 14. The uncertainty of a speedometer of a vehicle is 5%. The uncertainty of a speedometer is 5%, so it's not really a value, correct? It's 5%. Calculate the minimum speed the vehicle could be traveling if the speedometer reads 60 kilometers per hour. So remember, can I say this? What this question is saying is that if the speedometer is 60 kilometers per hour, it could be off by plus or minus 5%. That's what the question is saying. Like that's what your setup is. And do you notice the word calculate? Have you seen that? So you know it's not just gonna be just grab a bunch of numbers, right? Like you're just gonna have to do a bit of calculating here. So what I'm gonna do is I'm gonna find 60, right? I'm gonna multiply that by 0. What's 5% as a decimal? 0.05, yes. And that gives me 3 kilometers per hour. That's how much you can be off by. And by the way, that is very true with cars. Did you know that, right? It's not when it says 60, it may be that you're off, right? That's why police officers probably they don't stop you if it's 63 or 65 on a 60, but they will probably stop you if you're going 70, right? Because now you're way off. So the minimum. So this would get you a mark, by the way, you getting the 3 kilometers per hour. And then the minimum would be 60 minus 3 which is 57 kilometers per hour. So if your speedometer reads 60, you could be traveling as low as 57 kilometers per hour, or as high as, if it asks for max, I'm going to circle this as my final answer. But the max would be 60 plus the uncertainty, so 63 kilometers per hour had they asked for the max, right? But make sure you circle the answer and then you're fine. Okay. So 1 mark for this, 1 mark for figuring out the uncertainty as a kilometer. Good. Next one. Oh, now it's probability. Probability. Okay. What is the timeline for the province has set for us on that? Oh, 10 to 15 minutes as well. That's what they recommend. So how about you spend, I probably will go more like 10 minutes because I know you're pretty bright. Here's another expected value. So from marking the test, I need to cover that. I need to review that. So if you want to leave expected value for now and do all of the other ones, because the other ones won't take you long, right? We're talking odds, probability, stuff like that. Leave question 15 for now, unless you really want to do it. But I would do all the other ones in this section and then come back to this one and give it a shot if you feel like up for the challenge, right? So take some time. Ready? Here we go. Let's do this one first. I'm going to do it slightly differently. I'm going to try see if this works for you guys. Colin has a painting company. He advertises by delivering brochures. Each brochure costs $2.50 to print. If you've already read this, that's probably interesting. He finds that 1 out of 50 brochures results in a painting job where he earns $100. So 1 out of 50 is the chance that he will win $100, correct? And the cost to play the game, right? For every brochure he prints, it costs him $2.50. So I will do this. Let's take the way to win the first. There's only one way to win, right? So 1 times 50 times 100 minus 250, because that's the formula that I gave you. Let's just do that first. Figure out what that is. That would be 1 over 50 times, what's this going to be? 9750? Yeah, 9750. So you take the 1 over 50, right? 1 divided by 50, and you multiply by 97.5. So that's 1.95 right there. But there's something missing. We also need to, like, if 1 out of 50 is a win, then how many out of 50 would be brochures that don't get a job, don't get him a job? 49 out of 50. And there I just lose 250, right? Like for every brochure that people throw in the garbage or recycling, it's 250 that you lose every single time. 49 out of 50 times you lose the 250. Okay? So you don't have to subtract, because we subtract because you're really just gaining what's left over. So 49 divided by 50 times 2.5, that's 245. So this is win and this is lose. Right? Win, lose. So what do we have to do now with these two numbers to give our final answer? You add up all the winnings, right? And you subtract it at the end from the loss. So expected value is 195 minus 245. It's going to be negative, yes. That's dollars, negative 50 cents. Expected value. You would get 3 marks if you somehow show that you're coming up with that final correct answer. And this is not using that other formula, right? So this is win loss. And when I give you other exams, you might have instances where there's other ways of winning. It could be that 2 out of 50 brochures give them a $50 painting job, right? It could have said that, but it didn't. Okay. So what does a negative mean to us in the long run? Yeah, that we're going to be losing. We're going to be losing in the long run. So let's write this down. EV, it's either positive or negative. That's really what we're interested in. Gain, loss, right? This is good, bad, don't play. Okay. That's just a little aside there for you. Good, bad, remember that. So justify, remember that word justify when we went over all the keywords on when we started yesterday? Justify whether Collins should continue to deliver brochures on your answer, based on your answer in part A, and you would say he should not continue since a negative expected value indicates an overall loss. Yes. So overall, even if you win a few times, even if some people call you, you're gonna lose in the long run because the flyers are probably too expensive, or maybe you need to charge more, right? Maybe you need to charge a bit more to kind of offset the cost of those brochures that you're printing. All right, so same idea. It's still, you're kind of playing a game. When people are advertising, they're hoping somebody's gonna call that number or click the link or whatever, but it costs them, right? Right? You probably know, right? If you click on a link, someone is collecting some commission, right? That website that you found and you click the link that takes you to the store, they're collecting commission. It's almost like the brochure fee. Right? Okay, 16. I was hoping you were able to do this one. The odds against, they're nice enough to bold that one. Odds against breaking your pencil lead are against the event. This is the event. So that means that this number here is breaking, because the way it's worded, against breaking means that breaking is on the other side. So this is not breaking. You got to be very careful how you read these ones. Okay. All right. State the odds in favor. State the odds in favor of breaking your pencil lead. So this is as easy as flipping it, right? May the odds be ever in your favor. I just watched that movie the other day again. State the probability of breaking your pencil lead. So guys, this one, I would hope that this is a home run, right? If it says against, odds against, like what are the odds in favor, then just flip it, right? And then probability though, that's where it gets a little trickier. Okay, to go from, I'm just gonna plainly say it this way. Example, if you have like 3 to 5 odds, then the probability would be 3 over 3 plus 5. Yeah, in general, there are some nuances there, but remember that's the general rule. To get to get the denominator, you add these two numbers for sure, and that's your denominator. Whether you have to pick the 3 or the 5, it depends on the question. It depends on how they word it, right? In favor or against. Yes. State the probability of breaking your pencil. So probability of breaking, you don't have to have this part, by the way, but breaking is 7, correct? That is what we're after. And then down here will be 7 plus 323. So it's 7 over 330. Leave it. Do not turn it into a decimal. Do not turn it into a percentage. Just leave it like that. Okay. So when you're going from odds to probability, your first step should be, let's add the numbers and put that in my denominator. And then the top number, I have to decide if it's odds against, you would have to pick the 323. If it's probability in favor, probability against, probability in favor, against. Okay, let's keep going. Okay, Ariella spins the following spinner. Spinner is divided into equal sections. State the probability of the spinner landing on blue. State, that tells you that this is going to be easy and it's only 1 mark. So blue, there are 2 blue sections, 2 over 5. Done. That's it. Let's move on. See, it took you seconds to do this one, right? So that's why some are short and sweet, some take more time. I'm interested in this one, if you remember this one. Wooden blocks numbered 1 to 10 are placed in a bag. The blocks are the same size and shape. Your teacher pulls out 1 block, records the number, puts it back. She repeats the process 9 more times. So 10 in all, right? Her results are recorded below. So these are the results. Experimental, right? This should ring a bell, experimental. A student states that the experimental probability and the theoretical probability of pulling a block of 4 are the same. Explain why she's incorrect. Explain. So what I would do maybe is say theoretical probability of grabbing a 4 is what? Yes, 1 out of 10. The experimental probability of grabbing a 4, how many times was the experiment performed? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times as well. So in this case, the denominators are the same, but it happened 3 times, 3 out of 10. So I would say they are not the same. Since on the actual results, the 4 was drawn 3 times. This would be sufficient for this question here. State which block has the same experimental and theoretical probability of being pulled. Which of these blocks, like, let's see, 10 shows up, for every single number it's 1 out of 10, right, in theory? So you have to find the number that only shows up once. 6 shows up twice, 10 shows up twice, 5 shows up twice, so the 8 is the only one. 8 is the only one. Block number 8. Theoretical probability is equal to experimental probability, which is equal to 1 over 10. All right. Remember the difference between experimental, right? Experimental is based on what actually happened. I will just go up here. Maybe write this down. Theoretical, based on possible outcomes. Experimental, based on actual trials. Okay, so you need to have that. So in theory, rolling a 5 is 1 out of 6 every single time, right? But experimental, it's based on, okay, you rolled it 50 times, how many times did you get a 5, right? What's the key word here for them to be about the same? You want a theoretical probability should be close to experimental probability if sample is large, right? If you have a large sample, if you have lots of experiments, lots of trials, then they usually end up being very close to each other, if not exactly the same. Let's keep going. Some of us are writing this down. That's good. Go write it down. What's next? 19? Oh, yeah. You should be able to do 19. I'm fairly confident. Maybe not today because you're kind of lazy, but yeah, it's like, leave me alone. Like, let's face it, are you ever going to feel like reviewing? You're never going to feel like reviewing, so I'm kind of forcing you. Right? I could be teaching you new stuff. Instead, let's do this, right? All right. So every student gets one teacher like that. So I'm not the one. The chart below shows the numbers on each cube and possible sums, right? So 1 and 1 is 2. So these are my outcomes. So these are two six-sided dice, right, that are being used. How many outcomes are there in total? Yeah, total outcomes. Write this down. Total outcomes. 6 times 6, which is 36. Okay, there are 36 possibilities here in this case. State the probability of two cubes having a sum greater than 8. We've done this kind of stuff, guys. Sum greater than 8. Where's my 8 line? 8 line is always diagonal, right? So this is my 8 line, so I want greater than that. So I'm going to go write all of these ones here. Right? These are the ones. So how many are there? 1, 2, 3, 4, and 7, 9, 10, right? So probability of sum G8, I'm making stuff up. So it's 36, so there's 10 out of 36. 10, right, out of possible 36. So always try to come up with your total and come up with what are the favorable outcomes. In this case, there are 10 favorable, like the ones that we're after here. And remember, probability always adds up to 100, right? So a sum less than 8 would be everything else. Actually, there would have to be equal to or less than 8 if you wanted all the other ones. All right, let's keep going. Home finance. Oh, you write this down, yeah. You go to home finance. We did this not too long ago. What is it asking for there? A says calculate Mr. Reed's gross debt service ratio. What do we call that in short? GDSR. You should be able to nail that one. All right. I hope that that one, it's worth, the whole page is worth 4 marks. 4 marks on this test is a lot. So that's like if it's 3 or 4, pay attention. You got to be careful just because you don't want to lose marks for not including something. Let's do the GDSR. You try GDSR right now, okay? GDSR, it's on your formula sheet. Oh, go for it. Keep going, actually. Yeah, if you want to do the whole thing while I'm talking, go for it. Try GDSR, guys. Try GDSR. This one. You should be able to do it. The formula sheet is at the back of the booklet, right? I told you this. Just go to the back and keep flipping. GDSR is right here. Right there. It's basically just plug in and go. That's what I got. Yeah. What is the GDSR again? But what it does is it compares your housing costs to your income. And so I'll just say that here below because they're asking you to explain. If the GDSR is above, right, plus 32%, this is bad. If it's less than 32%, that is good. Okay, so you have to be careful. All these ratios and whatever have different ways that they will test you on it. Explain whether Mr. Reed will be approved for the mortgage. So what will you say? It's above 32, so no, right? Since his GDSR is above 32%, he will not be approved for a mortgage. Okay. So I honestly feel like 3 marks for this is a little bit too much, but that's what they do. And so it's actually not too bad if you're just careful, correct? Like 3 marks and you end up in your pocket, and then another bonus for just knowing Like I would have this on my study sheet next to GDSR, just like more than 32 bad, less than 32 good. Okay, let's do the other ones. I'm kind of gonna fly through. Describe the purpose of the following one-time costs. Lawyer fees. Why do you think you need a lawyer? You could say to transfer the title and ownership. Sorry, ownership. You could say to take care of the legal paperwork associated with the purchase of a home. So it says describe, right? So you need to be a little bit more detailed. To take care of the legal paperwork associated with the purchase. Sorry, it's missing with the purchase of a home. And sometimes if you don't hit the mark, we can sometimes give you half a mark if you're kind of in the ballpark. So hey, you're getting half a mark, right? It's better than getting a 0 on it. And next, home inspection, what does that do? Right? An inspector will look for potential issues with the house. This could be the roof, the basement walls, the wiring or electrical, etc. Right? Just use your imagination there. Explain. An inspector looks for potential issues with the house. Oh, we ran out of time.